Hello and welcome to my channel. So in today's video, we are going to talk about mass spectrometry. Mass spectrometry is one of the methods by which we can analyze molecular weight of a charged molecule. It separates molecules by mass to charge ratio and also it detects charged or ionized molecules in the gas phase, and charge comes from protonation events during ionization. Let's understand this. Mass spectrometry basically is an analytical tool which is useful for measuring mass to charge ratio of one or more molecules present in a sample. These measurements can often be used to calculate exact molecular weight of the sample. Typically, mass spectrometers can be used to identify unknown compounds via molecular weight determination. In a mass spectrometer, we use protein or peptide samples which involve weak or soft ionization, which means you need to ionize your protein sample first so that you can get the results. This is how a mass spectrometer looks like. Now let's understand how does a mass spectrometer work. There are three components in the mass spectrometer: ion source, mass analyzer, and detector. The first step, you put your sample in the sample inlet and vaporize it. Molecules are converted to gas phase ions in the ion source so that they can be moved about and manipulated by external electric and magnetic field. Remember, there are two types of fields used in mass spectrometer, that are electric field and magnetic field. Ion source in which you do ionization can be of two types, ESI and MALDI, and this we will learn later. Now, once you put your sample in the ion source, these molecules are converted to gas phase ions, and this method allows for creating positive or negative charges depending on the experimental requirements. Next is the mass analyzer. Once the molecules are ionized, the ions are sorted and separated according to mass to charge ratio. And there are a number of mass analyzers available nowadays. The mass analyzer often works with the ion detection system. In the ion detection system, the separated ions are then measured and sent to a data system where N to Z ratios are stored together along with their relative abundance. A mass spectrum is simply, this is a mass spectrum. It is simply the M to Z ratio of the ions present in a sample plotted against their intensities. Each peak, what you see here in a mass spectrum, shows a component of unique M to Z in the sample, and the heights of the peak are correlated to the relative abundance of the various components in the sample. Now let's check the ionization sources. There are two ionization sources, electrospray ionization and MALDI, that is matrix assisted laser desorption ionization. In the MALDI method, that is, this is called MALDI-MS. When your ionization source is MALDI, we call it MALDI-MS. And when your ionization source is ESI, we call it ESI-MS. So matrix assisted laser desorption ionization is called MALDI. We use a MALDI plate like this. In this plate, we already have grooves in which you can put your sample. Put your sample in the powdered form, which is already mixed with some volatile component. The matrix, that is called matrix. The matrix is a light absorbing substance that is excitable by a laser. So in this method, a laser pulse is directed onto a sample, which is mixed with a light absorbing matrix, causing the matrix to rapidly vaporize and carry the analyte molecules into the gas phase, where they become ionized and then they can be sent to mass analyzer and detected. Typically, it produces mostly singly charged ions, H plus ions, which simplifies spectrum interpretation, because when you know that all the charges are plus one charge only, then it's easy for you to identify the molecular weight. MALDI is often well suited for analyzing large molecules like proteins, peptides, polymers with high sensitivity. And this is how the spectra of MALDI looks like. Relative abundance versus mass to charge ratio. Whereas in electrospray ionization, a fine mist of the sample solution is sprayed through a high voltage capillary, causing the droplets to shrink and eventually produce charge ions. So if you can see here, two concentric steel tubes, they are carrying the liquid and nebulizing gas. After nebulization, additional gas is used to dry the droplets. So you'll put your sample here, liquid sample, it will convert into the charge ions. Whereas in case of MALDI, you need a dry sample, which you have to dissolve in your volatile buffer. Now, as the droplets shrink, the charge density increases to the point at which the droplets are no longer stable and ions are released from the liquid matrix into the vapor phase. Ions enter the mass analyzer at an angle to reduce the entrainment of neutral molecules. So in ESI, often it generates multiple charge ions, allowing for better mass accuracy and analysis of larger molecules by distributing the charge across the molecule. So in ESI, it is usually involves dissolving the sample in a liquid solvent and directly injecting it into the electrospray source. This is commonly used for analyzing complex mixture of molecules, including peptides, proteins, small molecules, which are often coupled with liquid chromatography for separation. A quick comparison. ESI adds a lot of charges to protein, allowing a large mass range, and spectra contains a series of peaks that differ by a single proton. Characteristic charge distribution is there, whereas in MALDI, most molecules pick up only a single H plus charge and it is not inline. That's all for the video.